whenever you talk about decentralized finance, the thing that actually allows the whole decentralized finance to work is smart contracts. So we've talked about a difference between centralized and decentralized finance. We talked a bit about Ethereum. Now we're going to talk a bit about smart contracts. So typically speaking, smart contracts could be written in various languages. The most common one is Solidity. There is a Python-like version of it called Serpent. There is a Lisp version and a C-like version. But essentially all it means is like you have some ability to combine data to policy, and you could actually use that to achieve this. And smart contracts should be nothing new to anyone. So society always had contracts, and there is always a contract for investment, employment, purchase, supply, real estate, construction, law, insurance, marriage. The list goes on. So the Bill of Rights, again, is the U.S. Bill of Rights, but that's again a societal contract in that sense. And societal contracts typically are written in language, and Magna Carta is another example. That's a legal contract that's actually written in language. And what has actually happened is from the language that's written, which is an abstraction, into a programming language. That's what actually happened, right? And this is what how a contract is described. A contract is an agreement creating and defining obligation between parties. Okay, so again, I am referring to other people. I am no legal expert, so my understanding of legal constructs are limited. So typically speaking, it's 4 steps. One is offer, which is like one party makes another party a proposal, acceptance of the party, or parties accept it. So then it is intention to be legally bound. Essentially, you put it down a contract. Consideration effectively, that's a win-win exchange of value. That's how the whole thing is supposed to go through. Now, what are smart contracts? No conversation of smart contracts will be complete without actually describing Nick Szabo in context. So when we're talking about different value of Ethereum, all the way from V all the way up to, I can't remember what the last one was, but somewhere in there was Szabo, as in Nick Szabo, right? So Nick Szabo is one of the first people to actually understand smart contracts, and he describes smart contracts. He actually wrote an article which was described as formalizing and securing relationships on public networks. So he kind of described this. The basic idea between smart contracts is that many kinds of contractual clauses can be embedded in hardware and software we deal with in such a way to make breacher contracts expensive for the breacher. So in a sense of speaking, what it's referring to here is, in an abstract sense, is the cryptoeconomic argument of having smart contracts. So what a cryptoeconomic argument is the breaking of a contract will actually cost the breaker of the contract, the breach of the contract's high. The value that's in the contract is it's much better for them to actually comply by the contract than to break it. So, and he goes on to describe smart contracts combine protocols, user interfaces, and promises expressed via interfaces to formalize and secure relationships over public networks. This gives us a new way to formalize digital relationships, which are far more functional than inanimate paper-based ancestors. However, we have been having challenges in having smart contracts. I mean, not because smart contracts are not just hard, but also because it's like the way we actually look at smart contracts is slightly different from how we've been looking at contracts. Contracts have been around for a very long period in time. Now, smart contracts only entered very recently, so it takes a bit of time for us to really understand exactly what it all means. So the best example I typically give for smart contracts is a vending machine, right? So why do you think of a smart contract as a vending machine? The reason I think of a smart contract as a vending machine is like it has a very well defined set of actions. It has a security margin, and it acts like a smart contract. So it takes coins. Okay, it has a finite item. So if you want to go to a smart contract, so a physical smart contract, this is a vending machine. You want to get, say, some iced tea out of it. So it only accepts a set of valid coins, and you put those coins in. Then there's a finite automator. It actually knows what the state of the machine is, how many green tea is there, can you vend it, and how much does it cost? So when you put the money in, if the value is about the value of the particular thing, and then you make a selection, it actually selects one and gives you dispenses the item that you've chosen and gives you the change. Okay. And the other things that you should recognize is limited loss. So if you look at most of the vending machines, you could see a big announcement written there saying, please don't try to break this. The total amount of money here is very limited. And this is also what Nick Szabo was kind of saying. It's like the effort that's required for the breacher to breach a smart contract is high, that it actually makes logical sense for the breacher to actually comply by the contract than to breach the contract. Okay. So now going on to something that is kind of related to smart contract, but is kind of important in the larger scheme of things, and we can't go around this. So in set of governance, so we have this construct a decentralized autonomous organization. The first of them I kind of briefly described. It actually came about in 2016, and it continues to be something that's important. Okay. So now we're going to talk a bit about wallets, keys, and other things, which is like MetaMask. So this is the way that we actually interact with DeFi. So let's think about wallets, and let's think about what wallets mean. So one of the constructs of public key cryptography is that you have two kinds of keys. It's a public key and a private key. And in the case of Ethereum, you definitely will have both Bitcoin and Ethereum. You have a private key. And typically you want to store the private keys in a somewhat secure manner. There are different ways you can actually store them. And typically you can have a software wallet, which is a wallet that you actually have in a browser or other piece of software. Or you could have hardware wallet. The hardware wallet will be a piece of hardware, something like this. You could recognize this. It's a Ledger Nano X. Or you could actually have even more sophisticated hardware wallet that actually has multi-signature capabilities, right? So the key thing here is, like, if your keys, private keys, are compromised, then the person who actually has access to the private keys has access to all the funds that are there, right? And in Ethereum, there's also this mechanism by which you could create mnemonics, which are like 12 words, which actually allow you to remember things, and then these words could be used to reconstruct. So essentially what that means is, in this instance, let's take the case of this. So in this Ledger Nano, when I initialize it, it could be this ledger, or I could also have a different one. I could have this ledger as well. So this is a Ledger Nano S. When I boot it up, it actually gives me 12 words, and if I write it down, then I can get another copy of this and then initialize it to the same state if I remember all the keywords. Okay, this is like a super important thing for us. Anybody who actually wants to get into DeFi, you need to have a hardware wallet, and you need to remember how to recognize how to initialize it and how to securely store it. And as everybody could know, like, storing anything written in paper is not a great idea. So paper wallets are not good, and the backup of this, the key 12 words that you produce is also pretty important. You have to be very careful about how you store it. So there is also the concept of offline signing, where you could actually do some signing offline, where you don't have to interact with the internet as we do. And the thing that I would say this is the most important thing that you would mostly see is MetaMask. The Fox phase of MetaMask is something you're probably going to always remember. Again, this is a browser-based wallet. You select the main network. I didn't go into different networks in Ethereum. Ethereum has multiple networks. The network that you're going to do most of the stuff on is the main net. Then there are test networks, Rinkespi and Robsten. So these are networks that you would actually use to test things. And then you can have a local network locally to actually do whatever you want to do. So in general, what happens is whenever you create a wallet, you have a public key and a private key. The private key is securely stored on your machine, and securely storing implies normally on a software or hardware. Hardware could be something like this, or like this, or even more sophisticated versions that are there, right? And you one of the things that everybody should recognize is every wallet has an address, and even though this is pseudonymous, which is essentially means it doesn't really translate to the person per se, but if you do transactions, every transaction goes through, it could be correlated to the person who actually does transactions, and it is likely that your identity could be revealed if you do lots of transactions. You, with a very high probability, will be correlated with, it's you who actually have this identity. Okay, so much for this, for the first part of the lecture on introduction to Ethereum for DeFi. So we shall talk again in the next lecture. Okay, thank you.